This conference will now be recorded.
Hello students, we had been discussing POIQs from JEE main papers. So we are still continuing with this second September evening session of 2020 paper. So let us start our discussions. Excuse me. So guys, in the last session we had some calculation issues with this problem. So that's why we did not get proper answer for this. Let me discuss this question first. A heat engine is involved with exchange of heat 1915 joule minus 40 joule plus 125 joule minus q joule during one cycle, achieving an efficiency of 50%. The value of q is, so look, in any heat engine the efficiency is work done by heat supplied. Okay, heat supplied. So here actually nothing is said as such, which one is supplied, which one is the work done, etc. But one thing you have to remember here, all the positive heat energies are actually supplied energy. So q will be 1915 joule. I'm sorry, this is heat input, I should say heat input or heat supplied, and here it is work output. So all the positive quantities here are actually heat supplied. So I can actually get heat supplied this plus 125. So 5 5 10, 1 adds to 2 3 4, this is 9 plus 1 is 10, this is this. So this is the actually energy which is supplied. Now look here, actually to get work output, you have to actually add all those three things. In the sense, see, I'll get work output by adding this with proper sign minus q and divided by this. Okay, so now look, so these two, and if you minus it, so you'll get here 2000 minus q divided by this. Now on the other side, see, this efficiency is given for this particular heat exchange, for this particular heat engine, it's 50%. That means I can write half. So I get 4000 minus 2q is equal to 2040. So I can write 2q is equal to 4000 minus 2040, and this gives actually, say, 4000. If you just, so this will be your value. Okay, 91960. This is equal to q, so q will be 980. So q will be 980 joule. So this is the answer. Okay, So we had actually done mistake yesterday with this addition. Okay, all right. Let us go to the next problem. So this problem says a figure shows a region of length L. Actually, this has got length L with a uniform magnetic field 0.3 Tesla. So here you can see that this magnetic field is 0.3 Tesla. Okay, in it, and a proton entering the region with velocity. So a proton is entering this region with a velocity 4 into 10 to the power 5 meter per second, making an angle 60 degree. So it goes like this. So this is actually 60 degree, 60 degree with it. So it has got two components, one along this way, another along this way. So that's what I can say from this figure. Okay, so if the proton completes 10 revolutions by the time it crosses the region L, it's close to, if the proton completes 10 revolutions, okay, 10 revolutions, the time it crosses the region L is close to. So I think these are in minute or something, or we'll just see. Time you have to calculate. Okay, see, in this case, one thing you need to note that this is a charge particle which is moving with a velocity, having two components, one along parallel, like one along the magnetic field and another along the direction perpendicular to the magnetic field. So I can get perpendicular component sine theta. So V sine theta is responsible for circular motion here, like this. Okay, circular motion. At the same time, it will actually make a spiral. Okay, this path will be actually spiral path. Okay, so V sine theta is a term which is responsible for the circular motion. So here I have to find out if the proton completes 10 revolution. So I have to find out the time it takes for a single revolution. Okay, then I'll get the total time. L, okay, I have to find out the length. Okay, so actually if I can find out the time period of revolution, suppose t or delta t, then I multiply 10. So this will give you the total time. Okay, this will give me the total time, and I know the velocity with which, so actually I have to find out the thickness. Okay, thickness L is close to. Okay, so I have to find out the thickness here, thickness or the like, yes, so thickness of this region. So I know the velocity along the magnetic field direction. So from there I can write actually V cos of theta into this t. This will be actually L. All right, so things are very clear now. So from the cyclotron like principle here also we can actually apply. So mv square by r, mv square by r is equal to vqv, right? vqv. So one v goes off here. So I have to actually find out time period, right? So let us find out then v. V is bq r by m. This is the velocity. Now what is the time? So I can write down 2 pi r, 2 pi r, if r is the radius. Okay, but that is not given anyway. 2 pi r by V. So what I get? 2 pi R divided by BQ R, and M will go in the numerator. So what I get is actually 2 pi M by BQ. So this is the time period of revolution. So then see, L will be 10 into this time period of revolution into V of cos theta. Okay, but now what is T? So this T will be actually this see, this T will be this V will be actually V sine theta. V sine theta. Okay, this is V sine theta. Here there will be sine theta. On sine theta will be there. So here there will be a sine theta over here. Okay, 2 pi m sine theta divided by, so 2 pi m 2 pi m by bq. Here there will be a sine theta by bq. Okay, so I can actually get the value 2 pi m sine 60 degree. Here sine theta is 60 degree. Okay, sine 60 degree is root 3 by 2. 2 pi m root 3 by 2 divided by bq. If I keep this, okay, so here L will be 10 into 2 pi. M is given for a proton 1.67 into 10 to the power minus 27 kg. 2 pi m, then it is root 3 in the numerator. In the denominator you have 2 into bq. B is actually 0.3 Tesla, and what is q? Q is actually 1.6 into 10 to the minus 19 coulomb, minus 19 coulomb. Okay, so this is actually the whole thing is 10 into t. Okay, then V is given 4 into 10 to the power 5 meter per second, and cos of theta is again cos 60 degree, that is equal to half. Okay, so what was the question here? The figure shows a region of length L with uniform magnetic field of 0.3 Tesla. So, and finally what we had to find out? We had to find out actually L. Okay, just a minute. I think see, finally we get a formula for T is this. Okay, so 2 pi m by bq. We no need to bother about this sine theta. Okay, I think that is extra term which is not required here. Other things are okay. All right, so 4 into 10 to the power 5. Then for cos theta, we have to write half. Then we have 10 2 pi m b bq to, okay, this 2 will not be there, this 2 will not be there then. Okay, so if you do this simplification, if you do this simplification, you must be getting 0.44 meter. Okay, so rest of the things are fine here. So you have to just do the calculations and see. So these actually approximately you can actually strike them out. Let us see the approximate calculation. Okay, then this you can write 2 and see this 10 power 5. If I just take this to numerator, so this will give you 24. So let me strike this out. So this will be 25. So you'll get actually 10 to the power minus 2. So these things are already done. This is also done. Now you have got here 4 pi into 10. See, 110 is here. So 4 pi by 30. So this is the kind of thing you get here. See, if we go for pi is equal to 3.14, if we just multiply that, so you get 6, 5, and then 12 divided by 30. This is like this. Okay, so this 12.56, you can approximately take this as 30. Okay, so sorry, 13. So you have to divide this 13 with 30. 0 point this. Okay, so 4. So then you get 390, another 10, so 3 like that. So you will get approximately this. You will see here, this is the answer. All right, so this is actually the answer. Now let us go to the next problem. Say this problem says a wire carrying current I is bent in the shape A B C D E F A. A B C D E F A, where rectangle ABCD and ADEFA are perpendicular to each other. So you can see that this is actually, see if I say this is XY, so this particular portion is in the XY plane. Okay, in the XY plane, this part is in the XY plane, and this is in the YZ plane, or anyway you can see this has a, like this plane is parallel to the Z axis. Okay, so they are perpendicular to each other, and according to this figure, so let us see what they have asked you to find out. The sides of the rectangles are of length A and B. See, this is B, suppose, oh sorry, this is A and this is B. It is already given. Now the magnitude and direction of the magnetic moment of the loop. So this is very simple problem. See, magnetic moment. What is magnetic moment? Magnetic moment is a vector actually. It is denoted by M. Okay, sometimes small m also. So magnetic moment, if I say magnetic moment due to A, B, C and D, this particular surface, that means this one. So you have to apply the thumb rule, okay, to find out the direction of the magnetic moment. We know the magnetic moment will be I into A. I into A. This is the magnitude, okay. I area, this is area, I is the current. So current I is flowing through all the like everywhere I is flowing. So you need to know the area. Area is AB. So I know the magnitude IAB. So this is the magnitude, but what is the direction of this magnetic field due to this one? Magnetic field, say this will be along k cap direction, along z direction. Okay. Other one is this one. For this, this will have, actually will have magnetic moment vector for DE or ADEFA. For this closed loop, DEFA, okay, up to this, this has got magnetic moment of same magnitude, but direction will be along IAB, along J cap direction. Okay. Now I have got two vectors, one along y-axis, another along z-axis. Okay, z-axis, this is y-axis. Okay, so what will be the magnitude and direction? Magnitude can be found out, and this is the direction. Okay, let us find out that. Say this is I cap and j cap anyway. So I have got the total magnetic moment. Say M ABCD vector plus. So MACD vector is actually along z direction, and then MDEFA. This is another vector, so which is along y direction. Now IAB, let us take this common. I have j cap plus k cap. So this is actually the vector quantity. I have to get the magnitude and direction both, right? So this is actually, oh, I see, this is actually, what, this is a vector. Okay, so I have to get, so I have to get the magnitude by taking a square plus b square. Okay, a square plus b square, square root of a square plus b square. Okay, see this square root of square root of a square plus b square. So that is I a, this is the magnitude, and direction anyway you have got that. Root 2, so we get root 2 ABI. So this is actually magnitude. Okay, since this is IBA, so you will get root 2 IAB. Okay, and what will be the direction? So this is the magnitude. I have to actually write the A I B I cap plus j cap. This is the vector divided by magnitude of that. So root 2 by root 2 this ABI. So this ABI and this ABI will get cancelled, so it will be square. So this is the magnitude along I plus j by root 2. Since it is actually say perpendicular to each other, so from there also you could have told that, I'm sorry, this is j plus k. Okay, not I plus j plus k cap plus j cap. So this is k cap The direction will be this way actually, and k cap j cap. Okay, so I hope you guys have understood this. So I had to find out both magnitude and direction. This is that is the reason I had to do this. Okay, so otherwise with this itself you will get the vector quantity. Okay, fine. Now we'll go to the next problem. So this is another problem which is also very important. Let us see what it is. An induction coil of resistance, oh sorry, reactance. This is not a resistance, so reactance, that means XL, reactance XL, when AC signal of frequency this is supplied to the coil, the applied voltage leads the current. You know, this is actually kind of going to be LR circuit because it will have by default some resistance. So in LR circuit, we know voltage is actually dominated by, like, voltage will be leading. So calculate self inductance of the coil. So we know 10 in this case when I have LR circuit, then I will have the impedance tan phi is equal to XL by R. Then how to find out what is XL? So this 10 for see phi is 45. So XL is equal to R. So XL is equal to R. We know Z impedance is equal to XL square plus R square. This we know, right? Calculate the self inductance. I have to find out what is self inductance. So here the question is, an inductance coil has reactance of 100 ohm. Okay, let me go ahead. See, this actually will get root 2 into XL. Okay. Actually, this reactance, this reactance you have to treat as impedance. Okay. That is where actually the clue was. This is not 100. Okay. So here XL is not 100. XL you have to find out. what is given is actually impedance. So XL is equal to Z by 2 root 2. So Z by root 2, what is Z? Z is actually 100 by root 2. So this is XL, or omega L is equal to that. L is equal to 100 by square root of 2 into 1000. I'm sorry, this omega is equal to 2 pi f. I have to multiply 2 pi here. 2 pi f. So 2 pi f. So 100 divided by, so I am writing 7 here, 20 pi in place of pi. Okay, 2 root 2000 here 22. So I think I am not going to do the whole calculation. Rest of the things are all right. Here you have to just find out what is, from this calculation, this will be nearly 1.12 10 to the minus 2 Henry. Okay, so this will be the answer. Option B will be the answer. Now we'll take up another problem. This is in a plane electromagnetic wave, the direction of electric field and magnetic field are represented by this and this. So you can see this is given as unit vector, okay, direction of B, but direction of B magnetic field is given in terms of vector. Then you have to find out what is the magnitude of this, sorry, unit vector, okay, unit vector. So how to find out unit vector? I have to find out, say, B vector divided by square root of magnitude of the vector. So magnitude of this vector is, you can see, so this is the vector and magnitude of the vector is square root of this square plus this square, 4 plus 4. So you get you get here how much? You get 4 root 2 2 root 2, so this will get cancelled. So you will get direction I minus 2j. I'm sorry, this both 2 will be getting cancelled. I minus j divided by root 2. So I have got two directions now. So B had got direction I cap minus j cap divided by root 2. Okay, I'll write it directly here. The direction is j cap minus divided by root 2. Now how to find out the direction? So I have to find out the direction E cross B. E cross B. So if you use the E cross B here, so now IJK cyclic rule we will apply here. So K cross I will be J only. So J cap. Kj will be minus I. So minus minus plus I divided by. So the answer will be Ij by root 2. Okay. So we'll move on to the next problem. So this problem, I think here I have, yeah, I have told you the option. Not JK. I'm sorry. This is IJ. Is there? I hope there is some mistake in the options. There may be typos here. So one will be IJ, I think. Here, IJ. 1 by root 2, this should be IJ. Okay. So this question says in a Young's double slit experiment, 16 fringes are observed in a certain segment of the screen when the light of wavelength 700 is used. And if the wavelength of light is changed to 400, then the number of fringes observed in the same segment on the screen will be. See, if I say this much region, some 16 fringes are accommodating. Okay, when the wavelength is 700. Now look one thing. If I know the fringe width, then multiply 6. So that will give you the length of this or width of this. Okay, if you know the fringe width, then multiply 16. Then you will get the. Now 16. That means the length is actually proportional to the fringe width. Fringe width. So if there are n number of fringes, then the whole length will be n into. Okay, so n into beta actually. So here in this case, so this place is actually 6 beta. Then another, and beta is again, beta is equal to d lambda by small d. Then beta is directly proportional to lambda. Okay, so from here we can understand that if there are n1 fringes, then n1 into lambda 1, this will be equal to n into lambda 2. So this is the formula you can use. So n2 I have to find out how many fringes will be there in the same region when wavelength of light is decreased. So N1 is 16, lambda is 700 angstrom, nanometer, 700 nanometer. Let me do it cleanly. By lambda 2, that means 400. 400. So this will be actually 28. So 28. This is the number of fringes with this wavelength will be 28. Excuse me. So we'll see this question. A particle is moving a 5 times faster as fast as an electron. The ratio of de Broglie wavelength of the particle to the electron is given. So particle wavelength p and this. This ratio is given as 1.87. It is 10 to the power minus 4. Excuse me. Now mass of the particle is close to. You have to find out what is the mass of particle. We know that lambda p will be is by mpvp, the particle, and for lambda it is. So now if you take the ratio, this is equal to, if I just write it here, see the MEVE divided by mpvp. So you have to find out the mass of the particle. Okay, so this factor you know already. So mass of the particle. So this is, see this part is here. So ME is actually 9.1 10 to the minus 19. So if you do the calculation, you will be actually able to get this one. Okay, this is very simple actually. So lambda p by lambda e, that is by, see if I just take the ratio, you will get this. So MEVE, you know, VE is actually, so the particle has got velocity 5 times faster than that. Okay, so this will be getting cancelled. So in the numerator there will be 5 into this, and this in the numerator there will be, so in the denominator I have to find out the MP, so MP I have got it. So VP is 5 times of VE. Okay, so I have only have this thing 9.1 minus 30 minus 31. Okay, so this will actually give you this value. So okay, so this problem says this is the next problem. So here it is said in a hydrogen atom, an electron makes a transition. This is n plus 1. Makes a transition from n plus 1 level to nth level. So there is a sorry, this will be a solid curve. So an electron actually making a transition from here to here. The question is, if n much greater than 1, then frequency of rotation emitted is proportional to. We know we have to see, we know the energy is actually E0 by n square. Okay, E0 is 13.6 etc. for hydrogen atom. Now when this transition is happening, so what is the value of this frequency of radiation emitted proportional to? So E is equal to h nu, right? So nu will be this is actually h. So the minus sign here. So if you want to have the change in the length, see that sorry, change in the state. So change the energy you will get and change the frequency. So change the frequency. How does it depend? We have to find out what is the change in the energy actually with the change in the frequency. Look here then. So 2 into E0 was there already. So E0 multiplied here. Then what is the change in the frequency? You see. So it will be actually proportional to 1 by n cube. Okay, you can see that from here. Otherwise also I can do in another way also. Look, I can do it. So E is equal to E is equal to minus RZ square. So this vector I am just writing as some K. K in final square, sorry, initial square minus final square. Now do the calculation. So minus K is there. This is H nu. So you will get here n square minus n square. Okay, plus sorry minus 1 minus 2 2n, and in the numerator you have n square n plus whole square. So you get, see, this thing cancel, and in the numerator you get 2n plus 1 whole into k, this is the constant, divided by n square plus n whole square. Now since n much greater than 1, I can neglect these ones, so you'll get 2n divided by, say, n to the power 4 here. That means what you get, see, there is a k here in cube only, so excuse me, this is proportional to 1 by n cube. All right, so I'll stop it here for today with this. In the next class we'll complete this session, like the questions with this session. Okay, so thank you for your patience. Bye for today.